discuss about what the meta model. So the meta model combines predictions from multiple base models and also improves overall accuracy using light GBM meta model. So when we are predicting something, here we are training our model. We are training with different models and we are combining together by using meta model. Here we have used PyTorch library. Generally, PyTorch is used for deep learning models like TFT. TFT means temporal fusion transformers, and NHITS, which acts as a base models in this system. And we are using Pickle library also. Pickle library is used to store the models into PKL files, and if they can be reused later without retraining. And also we are using one more model called warnings, because while training our model it gives some warnings. So warnings library is used to suppress unnecessary warning messages for cleaner output. And the main important is NumPy library. NumPy is used for numerical operations like array handling, mean calculation, and also we are using RMSE in here. So while calculating RMSE also it will be very useful to us, and feature concatenation also it will be helps, it helps to us. And another library is pandas. Pandas is used for data handling and especially for reading datasets and extracting time based features like hours and month. And light GBM is the main machine ML algorithm used as a meta model to combine predictions from different base models. And Matplotlib, we know that Matplotlib is used to analyze the data and visualize results such as error plots, prediction comparisons, and we are plotting true value and our prediction value, or we are all that one also we are plotting in the graph. And we are using one more is GridSpec. GridSpec helps in arranging multiple plots in the structured layout. That means without colliding anything, it will arrange in the specific manner. Time series split. Series split is used for time series cross validation, and also it happens on past data and testing on future data. That means it will ensuring that training always helps on past data and testing on future data. And one more last library is Pathlib. Pathlib is used for clean and perform platform independent file path handling. Next, while coming to the inbuilt functions, and also these are the paths we are using here. And root path is the parent path, and we are splitting our model, splitting our data. Here splits dir, and like that we are adding the paths. And here config tool is we are using, means we are splitting the data, and the horizon is 24, means here 24 hours we are training the data. So light GBM estimators and learning rate, here we are setting to 0.05, and max depth it will go means 4. Like that we are using this one. So when it comes to the function, that is load, this function loads out of fold. Woof means out of fold predictions from base models like light GBM, TFT, and NHITS. It also loads the actual values and masks the indicate valid predictions. Then it create a combined mask to keep only the data points where all models have valid predictions. This ensures the meta model is trained only on constraint and reliable data. So this function is doing like this. And when we go to the other function like load context features is the function generates time based contents. And here if you can see, it is based on horizon and stride like this. That means it is based on the time. That means these features like hour, month and day of a week, weekend flag. It also creates a cyclic features using sine and cosine to capture periodic patterns in time. If you see here, hour sine, hour cos and month sine, month cos. It means it is used to capture periodic patterns in time also. Here 2n pi dot ts hour by 24. That means it is related to hour sign. And finally, these features help the meta model to understand when certain base models perform better. Now, when we go to the other function like build meta features, this feature constructs the input features for the meta model. It combines the predictions from all the models, and here if you see, it is storing the it is storing the values in LGBM, TFT and NHITS, while we are doing pairwise differences. That means difference between, first we are doing LGBM TFT as LGBM minus TFT, means the difference. LGBM TFT indicates the difference between LGBM and TFT. LGBM NHITS represents the difference between LGBM minus NHITS, and TFT NHITS also like that only. Here after finding all these three, we are now doing the mean prediction. That means mean prediction equals to sum of LGBM plus TFT plus NHITS by total number. Total number is here we are using three models, so by 3. And we are concatenate means we are adding together all the LGBM, TFT and NHITS. This creates a rich feature set that all allows the meta model to learn the relationship between the models. Now, when we are going to other function, that is run meta woof indicates here learning rate and also maximum depth, and it uses the time series split to divide the data into training and validation sets without breaking time order. See, time series split. Here we are splitting the data into two parts. One is for prediction, one is for training. That means here short-term horizons uses a simpler model, while long-term horizon uses a more complex models. Finally, the trained models are saved for future predictions. After that, we are saving here np.save of track model directories, and we are storing in like npy like that. And when we go to other function, that is evaluate all, this function evaluates the performance of meta models and compares it with the base models. That means here only we are using RMSE root mean square error and MAE mean absolute error like that. Here we are using that one, and here for mathematical calculations we are using NumPy. Earlier we discussed about what does a NumPy will do. MA equals to NP dot, here mean of, this means mean absolute error means mean of NP dot abs. Abs is the function in NumPy, built-in function of A minus B. Here A is the validation and B is the predicted value. So RMS is the root mean square error. That means square root of square of the mean. It also calculates the performance for each forecast horizon separately. Finally, this helps to analyze how accuracy changes over time because it depends on RMSE and MAE. If RMSE is very less, then our model is predicting nearer to the actual value. So in this way, we will say that our model is accurate. Similarly, for like MAE also. Next, while going to another, that is plot. Here plot results is there. This function generates multiple visualizations to analyze model performance. Here we can plot the graph between MAE versus horizon, and mainly we are focusing on prediction versus actual. That means how the prediction values and actual values are closer to each other, and what is the best case and worst cases in that. And finally we are using the main function. This is also all related to the x1, that means axis, and these are all related to which color is using plotting techniques. These are all. Now while coming to the main function, so this is main driver function of the program. It runs the entire pipeline for each track, load, and we are using load, solar and wind. It loads data, generates features, trains the meta model, evaluates performance, and finally it will create the plots. This function integrates all components into a complete forecasting pipeline. So in this way, we are using meta model in our ML model.